Okay, so we're going to look at masks now. I'm going to quickly whip up this screen grab of a shot I worked on House of the Dragon. I think it's quite a clear one where it shows what masks can kind of do to enhance the surface. You'll see we have a range of frequencies and amplitudes and some like karma patches, which is kind of typical to what you'd see with actually looking at big bodies of water. So that's kind of what masks can do. It's a really easy, effective way of enhancing something and making it look less sort of like uniform. So yeah, let's jump into it. I'm going to hide that, and I'm going to go to the mask tab of our spectrum here. So immediately, if I enable, type. We'll start with type. Suppression and contribution, there's two. They actually don't apply to what you're doing here with the noise. It's a separate thing. That applies to the actual input you bring in. So if you bring in a mask area of like 1 here, 0 here, suppression would suppress here, not here. Contribution would do the opposite. It would contribute here, suppress here. So I think really that should be separated by a bit of a spacer, but you know, for the sake of that, it's fine. You'll see if I add the noise here, we actually get karma patches, and just to prove my point, if I change that to contribution, suppression, nothing happens. It's because it's using its own sort of range here. So let's actually look at the noise mask that's built into the spectrum. If I go to visualization, we'll see we're visualizing nothing. If I switch that to mask, we'll see a nice color thing now, which is very handy because it's super quick compared to actually looking at the geometry deformed. So it's very nice to sort of dial in your mask here. Now, I think it's a little bit confusing because when I think red, I think, okay, that's where it's suppressing because it's like 1, where it's actually the opposite. So if I look here, you see 1, let's say blue is 1, red is 0, which is usually the opposite to what it is. But for this, we'll say blue is the suppression. So if I look here, you'll see calm patch where the blue is, where the red is as if there's no mask at all. So it's quite important if you're going to use this to get your head wrapped around that. I think it's a little confusing because of those color switches. Maybe if it was contribution and actually did that, that would be cool, but it doesn't. So just keep an eye out for the colors of that. So red is basically don't mask. The blue end is like, okay, that's where the mask is being applied. So let's go through the parameters. Size is quite obvious. It's just the size of the patches. And a lot of these parameters are actually just similar to your standard noise that you might see in like VOPs. Roughness, for example, is just the roughness of it. If I just reduce this so we can actually see it a little bit better. Turbulence, just the turbulence of it. And then as well, offset down here is just the offset. So those are the kind of the noise-based ones. And then now we can actually move on to some of the movement ones. Direction, it's very similar to like the wind direction. It uses a 360 degree sort of angle pointer again. It's probably a good idea to have that somewhat linked to the actual direction of your waves, because often it probably won't be going against the waves if it's windy. So that's just something to bear in mind, but the option's there to change it. Straight away, I think this is way too fast by default. I feel like if you're looking at a windy surface, if it's really that windy, you probably won't have two calm patches. So if it's moving this quick, it probably doesn't make too much sense in my mind and looking at just general reference. So I tend to have the speed low, a lot lower, because I feel like that looks a bit more realistic. So that speed is just generally just how fast the mask moves. Pulse length is to do with the sort of the evolution of the shape. So if I reduce pulse length to something really short, you'll see that the shape of the patches changes quite quickly. Whereas if I go really high, the length is longer of the pulse, so the shape doesn't evolve to something new that quick. So in general, I tend to have the speed low and the pulse length high, because that just makes sense to me from what I've seen with general reference and working on shots. But you know, you might get a specific reference where it is a fast moving mask and the calm patches evolve quite quickly. There you go, you have an option to change it. We've done offset very briefly, obviously that's to do with the noise. Now input range and output range, this is where it kind of coincides with the colors, where I think is a little bit confusing. So if I go to view the actual deformation grid, and I'm just going to up the size now so it's a little bit clearer and we can see some patches here. So output range and input range, you'll see if I actually change the output range, well, first of all, the input range is basically just the inputs of the noise, and it's being remapped to 0 or 1. I think it's a little counterintuitive that 0 basically means full mask and 1 means no mask. I think it should be the opposite way around. Because if you see, if I up 0 to 1, our mask disappears. And as I lower that, you'll see our mask appears. And that coincides with the blue patch here with that. So I would argue that it should be the opposite way around, but it's not. So, I'll deal with it. This is good because let's say you don't want it to be fully patched of like a calm. You don't want that. You want some suppression, but not all. We can just up that to 0.5, maybe a little lower, like 2.5. And then if I just enable the mask and off, you can see it still has its effect, but it maintains the general look still of our spectrum. We get some breakup and stuff, kind of like what I was talking about with here. We want some calmer patches, some less amplitude in spaces. This is a quick and easy way of just kind of dialing that in. And again, you can alter the 1 and that would adjust everything. So if you wanted to bring everything down, like a remap of whatever. So we still want our plain 0 patches, but we want our full no mask ones to be brought down still. We can reduce that still. Obviously that has an effect on everything at that point. So I probably wouldn't alter the 1. I'd most likely change the output range, raise that slightly, because I think if it's at 0, unless you're applying multiple spectrums in these areas, I feel like a completely calm patch, especially on a spectrum with this kind of roughness of a wave, it looks a bit odd. So I'd probably bring that up. Yeah, that is an option. You also have this blend with spectrum option, which you can enable, and you can input a spectrum here and it will kind of blend the mask with that. I personally don't really use that. You're more than welcome to. I'm sure there's plenty of documentation and a few other tutorials that use that. You basically just plug in a spectrum wherever it is. I only have one really, so actually won't make a difference here, but it basically blends the mask with the spectrum. For the most part though, if you're doing multiple, I wouldn't worry about that, but the option is there. So now that is the built-in noise mask that comes with it. Right, so we're going to look at custom noise masks now, rather than use the built-in one here on the spectrum. So to do this, we need to generate a volume. We can plug usually just a volume into the input geometry. It's not the most efficient because if you've got like a weird shape, then it's just taking the bound of that, but it's better than just creating a generic volume X amount size when you might only need the small section. So by just using this, it keeps it down just to the bounding box of our input. So we're going to get a name of density. So we have our density field and an initial value of 1. And what we're at, 250,000. Let's give it a few more. I don't know why that's doing that. There we go. Give it a few more voxels there. So we're going to place a volume bump down now, and then we can add a noise. You can use turbulent, anti-aliasing, or whatever you want. I like AA noise just because it gives a nice pattern. And we're going to multiply our density by this noise here. So if we look at our Tommy reference, that's probably a bit too high frequency. So I'm going to drag all the way down. Maybe something like this. Give it some random offset. Maybe even lower than that, to be honest. Maybe something like this. I'm thinking deep ocean kind of thing. Not sure why Tommy's out in the ocean, but he is for this, so I apologize. So I'm thinking something like that for our calmer patches that are going to be suppressed. So now with the noises and stuff and volumes, I found it's easier just to remap the density values yourself, just to get more of control of what is actually suppressing fully and what's not. So what I tend to do is I just put a clamp and a fit range down, and I clamp the max value here and I paste that into the the max value in the fit range. That way if I lower that down, it kind of attenuates the peaks more, and we can control it an overall amount here that it suppresses. I just find that rather if you don't do any of this, I'll show you now, if I plug it in to this, we don't really see much, whereas if I bring this back, we have a nice amount of control excuse me, of like what our most suppressive part of the mask is going to be. And then we can obviously reduce the amount, so we have full suppression, half suppression, no suppression, or we say everywhere else at least half suppression, and so on. and we have that kind of control of like, okay, how far along this density map do we want to, you know, have the most amplitude. So that's really kind of the gist of it with a custom mask, I think, is you can just basically layer and layer and layer a bunch of these. You can obviously have multiple, you can have different ones with different noise patterns, different frequencies. You can combine the two if you do a volume mix, for example, and we set it to, where's maximum, plug that in there, and like that you can kind of see, if I just do that, you see it changes, and then you can have varying masks in different places. And of course you can have, let's say you've got two types of spectrums here. Let's say we don't want to mask on this for a second. Let's change this to be, I don't know, we're going to make it purposely bad, and then this one is this masks, and then we can merge these two like this, like that, and it looks really bad, but you get the idea that you can have specific masks with specific spectrums and then combine them all eventually. So hopefully that kind of gives you an indication of how we can sort of build up a complex spectrum layer sort of setup with different frequencies, different masks. There are other ways you can generate masks. You could, for example, an attribute paint is a good one. If you want, I don't know, let's say I want this bit here, this bit here, and this bit here. Well, we could just, there's a few ways we could do it. I guess we could scatter some points. We can say, okay, just do it in the mask, please. Let's make sure you have lots, and then we could just give that a density value, and then rasterize the attributes for that. Hopefully the p-scale won't break my memory. There we go. And then let's just revert to this one temporarily, get rid of that mask, put this one in, and you'll see, there we go. So it's basically just, you're making a volume mask. How you go about doing that's up to you, noise, paints, whatever, and then obviously you can remap that here. Now the only other thing is, as I mentioned before, there's two types, suppression and contribution. If suppression obviously suppresses the area that you give, contribution does the complete opposite. So if you want things to only appear in these masks, you set it to contribution, and there you go. And then just for the sake of proof, you can combine them all again with contribution on that, suppression on that, whatever. And as well, you can also stack with the built-in noise one as well. Just be careful with, obviously, with this, because you could like trip yourself up with these output range, because obviously they're two different masks. But for the most part, I would tend to stick with these your own custom volume masks, just because if you want them to still move, you absolutely can. You just, you know, plug in time into the offset and so on. Yeah, that's custom masks in the spectrums.